light and electric current. Introduction. The world is largely known through the senses. The sense of sight is one of the most important senses. It is only when light from an object enters our eyes that we see the object. The light may have been emitted by the object or may have been reflected by it. A polished or a shiny surface can act as a mirror. A mirror changes the direction of light that falls on it. Laws of refraction. The incident ray, the refracted ray, and the normal at the point of incidence lie on the same plane. For a given pair of media and for a particular color of light, the ratio of the sine of the angle of incidence to the sine of the angle of refraction is a constant. That is, sin I by sin R is equal to constant. The second law is also called Snell's law. Regular and diffused reflection. Imagine that parallel rays are incident on an irregular surface as shown in the figure. Remember that the laws of reflection are valid at each point of the surface. Use these laws to construct reflected rays at various points. Are they parallel to one another? You will find that these rays are reflected in different directions. When all the parallel rays reflected from a plane surface are not parallel, the reflection is known as diffused or irregular reflection. Remember that the diffused reflection is not due to the failure of the laws of reflection. It is caused by the irregularities in the reflecting surface like that of a cardboard. On the other hand, reflecting from a smooth surface like that of a mirror is called regular reflection. Images are formed by regular reflection. Multiple images. Take two plane mirrors. Set them at right angles to each other with their edges touching. To hinge them, you can use adhesive type. Place a coin in between the mirrors. How many images of the coin do you see? Now, hinge the mirrors using the adhesive type at different angles, say 45 degrees, 60 degrees, 120 degrees, 180 degrees, etc. Place some object, say a candle, in between them. Note down the number of images of the object in each case. Set the two mirrors parallel to each other. Find out how many images of a candle placed between them are found. In both cases, a number of multiple images are formed. Dispersion of light. Get a plane mirror of a suitable size. Place it in a bowl as shown in figure. Fill the bowl with water. Put this arrangement near a window in such a way that direct sunlight falls on the mirror. Adjust the position of the bowl so that the reflected light from the mirror falls on a wall. If the wall is not white, fix a sheet of white paper on it. Reflected light will be seen to have many colors. The mirror and water form a prism. Splitting of light into its colors is known as dispersion of light. Rainbow is a natural phenomenon showing dispersion. The human eye. The eye has a lens made of tough, gelatinous material. The lens forms the image of an object on the retina, which is at the back of the eye. The retina is covered by a large number of nerve fibers, very sensitive to light. They carry the impression to the brain by the optic nerve. The pupil is a hole in the middle of the colored diaphragm called iris and appears black because no light is reflected from it. The iris adjusts the amount of light entering the eye. The ciliary muscles alter the focal length of the lens, enabling the eye to adjust itself to objects at different distances. This action of the eye is called its power of accommodation. Least distance of distinct vision is the distance beyond which objects can be seen without strain by a normal eye. It is about 25 centimeters. The defects of the eye: short-sightedness or myopia, long-sightedness or hypermetropia, and presbyopia, astigmatism. Short-sightedness or myopia. Short-sightedness is a defect of the eye when distant objects cannot be seen clearly but nearby objects can be seen clearly. The short-sightedness can be corrected using a concave lens, divergent lens of suitable focal length. This lens has negative power. Long-sightedness or hypermetropia. In the case of the long-sighted person, distant objects can be seen by the eye, but nearby objects cannot be seen distinctly. Long-sightedness can be corrected using a convex lens to converge the light before it falls on the eyes so that the image falls on the retina. The lens has positive power. Refraction of light. When a beam of light traveling through air enters another medium like glass or water, its path bends as shown in figure. This bending or change of direction of light when it passes from one medium to another is called refraction. The angle between the incident ray and the normal is the angle of incidence, and the angle between the refracted ray and the normal is the angle of refraction. The boundary of the surfaces is called the surface of separation of the two media. In figure O is the point of incidence. POQ is the surface of separation. Angle AOM is the angle of incidence. Angle NOB is the angle of refraction. When a ray of light travels from a rarer into denser medium, it moves towards the normal. Therefore, the angle of refraction is less than the angle of incidence, or R is lesser than I. When a ray of light travels from a denser to a rarer medium, it moves away from the normal. Therefore, the angle of refraction is greater than the angle of incidence, or R is greater than I. Braille system. The most popular resources for visually challenged persons is Braille. Braille system has 63 dot patterns or characters. Each character represents a letter, a combination of letters, a common word, or a grammatical sign. Dots are arranged in cells of 2 vertical rows of 3 dots each. Patterns of dots to represent some English alphabets and some common words are shown below. These patterns, when embossed on Braille sheets, help visually challenged persons to recognize words by touching them. To make them easier to touch, the dots are raised slightly. Visually challenged people learn the Braille system by beginning with letters, then special characters, and letters combinations. Methods depend upon recognition by touching. Each character has to be memorized. Braille texts can be produced by hand or by a machine. Typewriter-like devices and printing machines have now been developed. Electric current. Metals such as copper and aluminium conduct electricity, whereas materials such as rubber, plastic and wood do not conduct electricity. Liquids conduct electricity. Collect a few small plastic or rubber caps of discarded bottles and clean them. Pour 1 teaspoon of lemon juice or vinegar in 1 cap. Bring your tester over this cap and let the ends of the tester dip into lemon juice or vinegar as shown. Take care that the ends are not more than 1 centimeter apart, but at the same time do not touch each other. Does the bulb of the tester glow? Does lemon juice or vinegar conduct electricity? When the liquid between the 2 ends of the tester allows the electric current to pass, the circuit and the bulb glows. When the liquid does not allow the electric current to pass, the circuit of the tester is not complete and the bulb does not glow. Chemical effects of electric current. Conducting electricity. Take about 2 teaspoonfuls of distilled water in a clean and dry plastic or rubber cap of a bottle. Use the tester to test whether distilled water conducts electricity or not. What do you find? Does distilled water conduct electricity? Now, dissolve a pinch of common salt in distilled water. Again, test. What do you conclude this time? When salt is dissolved in distilled water, we obtain salt solution. This is a conductor of electricity. Acids, bases, and salt. Acids, bases, and salt conduct electricity. Take 3 clean plastic or rubber caps of bottles. Pour about 2 teaspoonfuls of distilled water in each of them. Add a few drops of lemon juice or dilute hydrochloric acid to distilled water in one cap. Now, in the second cap containing distilled water, add a few drops of a base such as caustic soda or potassium iodide. Add a little sugar to the distilled water in the third cap and dissolve it. Test which solution conducts electricity and which does not. What results do you obtain? Most liquids that conduct electricity are solutions of acids, bases, and salts. Take out carbon rods carefully from 2 discarded cells. Clean their metal caps with sandpaper. Wrap copper wires around the metal caps of the carbon rods and join them to a battery. We call these 2 rods electrodes. Pour a cupful of water in a glass or a plastic bowl. Add a teaspoon of salt or a few drops of lemon juice to water to make it more conducting. Now, immerse the electrodes in this solution. Make sure that the metal caps of the carbon rods are outside the water. Wait for 3 to 4 minutes. Observe the electrodes carefully. Do you notice any gas bubbles near the electrodes? We call the change taking place in the solution as chemical change. The passage of an electric current through a conducting solution causes chemical reactions. As a result, bubbles of a gas may be formed on the electrodes. Deposits of metal may be seen on electrodes. Change of color of solutions may occur. The reaction would depend on what solution and electrodes are used. There are some of the chemical effects of the electric current. Electrolytic refining. When a metal of high purity is required, electro-refining is done. The impure metal is made as anode. A pure thin sheet of the same metal is made as cathode, and an aqueous solution of the metallic salt forms the electrolyte.